to 0.
Very good. Or,
Undefined.
I'm going to cross this out. I'm writing it so we never forget that we have to look at it, but not for this function. Its polynomial is always defined. Good. How do we solve this equation, or can anyone give us the solutions?
I'm a little confused why we cross out the undefined again.
So can you give me any x value for which if you give me x equals something, something, I will not be able to determine h prime? Is there a value that if you say evaluate this function, and I will say, sorry, I can't?
No.
No. If you give me 10,000, I will give you a number. If you give me negative 1,500, I'll give you a number. If you give me 0, I'll give you a number. Polynomials are always defined, and this is a polynomial.
Okay.
Better? Perfect. Good. So what do we do? How do we solve this for x?
We need to put 3.
We divide by
then-
3. X squared minus
and
9
then
equals 0. Yes?
So it's x plus 3 and x negative 3.
Good. Immediately I go back to the table, put it in the correct spot, put 0 underneath. What is the next step? After we found the critical numbers, so these are critical numbers. We put them in the table, we put 0 underneath. What is the next step? What am I trying to do next? Exactly what we did before. I need to fill in here, and here, and here. What am I trying to find?
Signs.
Yes. So let's plug in a number like negative 10 in here, and give me the sign. Plug in 0, and give me the sign. And plug in 10, and give me the sign. Let's start with the easy one. When I plug in 0, what sign do I get?
Negative.
Excellent. Now let's plug in negative 10. 3 times 100 minus 27. What is the sign?
Positive.
Very good. Let's plug in 100, or 10. 3 times 100 minus 27. What is the sign?
Positive.
Very good. The next step is we have to plug in, I need a value here, as we did before. Critical numbers, and then the corresponding function value, and then a corresponding function value. So here's what I recommend in y equals. In y equals, clear anything else you have in there. And let's put in x to the third minus 27x. And then I plug in. I need to plug in 3 and negative 3. Negative 3 and 3. So 54 and negative 54. 54 and negative 54. At this point, I stop. I need to make sure that this row and this row work well together. What does that mean? What does it mean they work well together? So let's try. What does the function do between negative infinity and 0? A function that is coming from negative infinity to 0, what does it do? From negative infinity to 0. Good. Is that supported by the sign of the first derivative? Are they in sync or not?
Yes, it's increasing.
Good. From 0 to 54, what does the function do?
increasing.
Is that supported by the sign of the derivative?
Yes.
What does the function do between 54 and 0? Decreases. Is that supported by the sign of the derivative?
Yes.
What does the function do between 0 and negative 54?
It's decreasing.
Is that supported by the sign of the first derivative?
Yes.
Finally, I shouldn't say finally, but between negative 54 and 0 and infinity, yes. What does the function do?
It's increasing.
Good. Is that supported by the sign of the first derivative?
Yes.
Yes. So we conclude that these two rows work well together. It means that it's very unlikely that we made a mistake. Okay. Now, can anyone identify what type of point is negative 3, comma 54? Negative 3, comma 54. What type of point is it?
The relative maximum.
Thank you very much. Any questions on this? You see the arrows, right? What type of point is 3, comma negative 54?
Relative minimum.
So we found the intervals of increasing, decreasing. We found the relative max, relative min. We're done with these two. We're continuing the second derivative. We want to find concavity and inflection points. And then we are ready to graph. So, can anyone give us the second derivative?
It's going to be 3x. I mean, not 3, 6x.
Very good. So we have two things to worry about. When 6x is 0 and when 6x is undefined. Again, we're going to cross this out. What does this mean? X equals? Anyone? 0, of course. Very good. So then I go back. Under 0, I will put 0 in. I already have the function value. It's already there. But now I need the sign here and here. So let's plug in a number to the left of 0 and a number to the right of 0 in the second derivative, of course. We're analyzing the second derivative now. So to the left of 0, plug it in and tell me the sign.
Negative.
So this specifies that I cannot forget when the second derivative is negative, the function opens downward to the other side of 0. Plug in any positive number and tell me the sign.
It's positive.
Good. Which means the function holds water. Now, what type of point is 0, comma 0?
Lower minimum.
Careful. We can no longer have any max min. We're done. We're done with max min. We cannot analyze the second derivative and come up with more max min. That's only for this first derivative.
So point of intersection.
Point of inflection, the IP. The 0, comma 0 is the IP. The second derivative is 0 and it changes sign. Excellent. That's all I need to graph the function. Everything else is gone, not important anymore. The table will tell us how to graph this function. Nothing else is important. So careful how we read the table. First, we have to plot negative 5.20, negative 354, 0, 0, 3, negative 54, 5.20. That's my starting point. I have to put in the points I have. Because this is such a big number, I'm going to fudge it in the sense that I'm going to take a unit so that this works. Okay, so negative 5.2, that's okay. 1, 2, 3, 4, 5.2. 1, 2, 3, 4, 5.2, let's say. 0, 0 is very clear. But negative 3, 54, I'm going to say 10, 20, 30, 40, 50, 54. So this is 50. 1, 2, 3, 4, 5. This is negative 50. So a positive 3 is negative 54. A little bit higher. Okay. So I positioned all the points. And now I read the table. Slowly but surely. From negative infinity, the function is increasing to the x-intercept opening down. One more time. From negative infinity, the function is increasing to the x-intercept opening down. Okay, fine. The function continues to increase to the point of relative max, still opening down. Now the function is decreasing, still opening down to the point of inflection. At 0, 0, the function changes concavity. All the way from now on, it will open upward. It will reach its relative minimum, opening, decreasing, and opening up. It will come up, increasing, still opening up, but this time increasing, crossing the x-axis and going to infinity. And this is the graph of f of x equals x to the third minus 27x. Moving forward, you are not going to need a graphing calculator. You are equipped with all the information you need to graph any function, almost. So the key is the table. Every time I find something, I put in the table to summarize it in here. Every time I find something, I put in the table. I have to make sure that the rows work well together before I move on to the second derivative. Because if I have a mistake here, I will have a bigger mistake here. So these two rows, in addition to and adding to them the second derivative, I will be able to graph any function, almost. I don't want to generalize 100%. Now, see, this is a critical number, right? It's a critical number, a critical point, so it's a relative maximum. Does it make sense for the second derivative to indicate this? Yes, because it could not be the other way. It could not hold water once it has a relative max. So these two also I can check. If it's a relative max, the function here has to open upward. Has to open downward. Here, the function has a relative minimum. It has to open upward. Otherwise, how can it have a relative min? If it has a relative min, the function cannot do this. It has to do this. So this is a sophisticated piece of information. So first we find everything about the function. Then we find everything that we can, those three things about the first derivative. Then we check that these two rows work well together. And then we analyze the second derivative for concavity and inflection point. And yes, if you want to convince yourselves that you chose the function, I didn't look at the function before, so we have the function here. We know what viewing window we need because it goes to negative 54 at the bottom and to positive 54 at the top. Using a zoom 6 is not going to work. We already have the graph. We know how it looks like. But we know that the standard viewing window, this is not going to work. We did all the necessary step-by-step work. So I know that I have to adjust the viewing window. I only need -7 maybe to 7 for the x-axis. But I definitely need negative, oops, I didn't mean that. That has to be 1 in this case. So definitely I want, let's say, -60 to 60 with a scale of 5. And now I will see what I need to see. And that's what I expected to see. Because we knew, we graphed it. So we knew what the viewing window should be for this function. Okay? Any questions? So
I
this,
have a question
yes?
about the inflection point.
Yes.
How come it's not 0.6?
Oh, because when we determine 0, we don't plug it in the second derivative. It will be 0. So when we determine where the second derivative is 0, we have to plug it in the function. See, when we determined the critical numbers, we didn't plug the critical numbers in the first derivative. We plugged them in the function. The point is determined as x comma y, not x comma y prime.
Oh, okay. So we're just looking to see if like it's possible for an x to be 0 on that one, not what it would be to be 0.
If we don't find h double prime being 0 or undefined, then there is no inflection point. But the point is given by the y value, not by h prime or h double prime.
Okay, I got you.
Better?
Yes, thank you.
Thank you. Okay, so I know we have a few more minutes left. Let's look at a word problem this time. Okay, so for example, for 41, we're not going to graph because we're not going to have time. It takes, as you saw, you know, the first problem, of course, is long because I have to explain every little thing. But moving forward, once you practice, it will take you much less. But let's look at gotta have it device is introduced in a market with such and such, the unit sales. So we do have the unit sales modeled by this function. S is the total sales in millions of units. In millions of units, X, okay, month after the device was released, fine. So find the point of inflection and interpret its meaning in terms of the rate of change. So it's a very good thing to look at. So would you like to do that? Is that okay?